Next Curve.
Hey everyone, welcome to Next Curve's Rethink webcast and our Analyst Corner. I'm Leonard Lee, Executive Analyst at Next Curve, and welcome to this episode of Silicon Futures, where we cover the stuff happening in the semiconductor industry and all things AI, supercomputing, computing, etc., that matter. And before we get started, please remember to like, subscribe, and share and support the Next Curve Rethink podcast. You can find us on YouTube and on Buzzsprout. We will provide information at the end of this episode, so stick with us. And in this episode, Karl Freund, who is the founder and principal analyst at Cambrian-AI Research LLC, is joining me for a very long overdue update on all things AI computing. And he is a leading analyst covering the semiconductor industry. And we are collaborating together on the series on AI PC and AI, well, maybe not AI PC. Karl he doesn't fancy the PC stuff as much as he fancies all that big supercomputing.
Big stuff.
Oh yeah, you only like the big stuff. So hey, Karl, wow, it's been a while, and it's so good
good to see you
this again with you. Yeah, I'm looking for the update because we haven't chatted in quite a bit, and that's a travesty, quite honestly. I think it's quite criminal. But we're going to have an interesting discussion here, right?
Yeah, there's lots going on, that's for sure. Always lots going on.
Yeah. So let's jump into this. So the first thing we wanted to talk about was, providing. Well, I want to get your update and get up to speed on what you've been up to, number one, and get an update on AI computing and AGI. I know that's something that you're starting to delve into a bit more, given that's sort of like the leading edge of where the discourse around quote unquote AI, right?
Yeah, it's the next big thing.
Yeah, which I think for the most part is that bleeding edge of generative AI. So yeah, I mean, what's going on?
Boy, so much is going on. I guess last time we talked might have been shortly after Computex.
Yeah,
we talked a little bit about what, AMD stepping up to a annual cadence, very similar to what Jensen's doing in NVIDIA.
Yeah.
Increasing chip size, increasing complexity, increasing HBM. That stuff gets kind of boring after a while. It's like, oh yeah, they're faster and faster and faster and more memory, and what else do you expect?
Yeah.
So I've been focusing lately more on learning about artificial general intelligence. This is the Terminator scenario. This is the one that folks like Stephen Hawking and even Elon Musk have predicted could destroy humanity. So I thought, yeah, it might be worth a little time to read about it and try to understand what's going on.
Sure.
Fundamentally, let's just start there, because I think everybody probably has a good handle on NVIDIA and AMD and Intel. We can touch base on that as well. But
Sure.
With AGI, we're really talking about having a machine that can pretty much do everything that a human could do in terms of problem solving, question and answers, research, and so forth, but across all domains and with a real understanding of the physical world. Let's not forget that large language models are really stupid. They really don't know anything but probabilistically what is the next word.
Yeah.
Which is pretty hard to believe. I mean, I've been playing around with complexity. It's really cool. And it's hard to believe that's all it's doing. It sure seems intelligent, doesn't it? But is it really?
Yeah.
Is it really intelligent?
It's the illusion of intelligence and reasoning.
Well said.
Is really what it boils down to. And you know what? Quite honestly, that is what Sam Altman has been saying from the beginning. Right?
Well, now,
yeah.
Sam has been saying we'll get to artificial general intelligence sometime in the next 3 to 5 years.
Yeah.
I think he said 3 to 4 years. I don't know how he's going to get there. Elon Musk says he'll get there in a year or two. So Sam and Elon, if I can call them by their first names as if they're friends, they're not. Um, they believe in something called, scale is all you need, right? I mean, this whole thing started with a white paper from Google called "Attention is all you need."
Right.
Well, now they're saying scale is all you need. Make it bigger and bigger and bigger, and eventually it'll become intelligent. Which I find very hard to believe, given that it has no understanding of the physical world.
Yeah.
It does not understand basic human concepts. It doesn't understand problem solving.
Right.
But it can sure predict that next word, can't it?
Yeah.
Which is, I'm not saying that's bad. You can do a lot of great stuff with predicting the next word, especially when you start applying it to other domains. But artificial general intelligence I believe, will require a different approach than large language models. A bigger large language model will appear even more intelligent, but it will still not have a grasp of the physical world. It will not have a grasp of human values. Will not have a grasp of even basic mathematics. So, there's different approaches. There's spiking neural networks. There's something called neural symbolic computing, which is interesting.
Oh,
because symbolic computing that's the old AI, right? Back when we were kids, there was symbolic computing. It never went anywhere.
I was probably an embryo.
You were probably an embryo, and I was a kid. But so there's a lot of interest now in bringing up things like symbolic computing as a way to solve the knowledge problem that large language models have, and use the large language model portion as a communication platform. So there's also quantum computing. I would say if it takes quantum computing to achieve artificial general intelligence, then we're probably 10 years away. But we'll see. There is a lot of research being poured into it. However, the excitement around large language models continues to build. And therefore, that's where a lot of the money is going. And so that's taking money away from the research, perhaps, of true artificial general intelligence.
I was on a opening panel for IoT marketing. They hosted a AI summit, and I said exactly that. I mentioned exactly that, and also your comments about a different approach. What we're probably looking at here with transformers and the current approach toward large language models, and now mixture of experts, and then moving toward multimodality. These are just creating the illusion of intelligence, of multimodality. But when, very early on, as I was looking at this stuff, especially as a lot of our silicon, our semiconductor friends were introducing us to transformers and a lot of these early generative applications, that was one of the things that I noticed, especially amongst startups, is that in the back end, they were just stitching together these individual models together to give the illusion of augmented intelligence. And so, and when you think about how energy inefficient this approach is, and how difficult it's going to be to continue to scale, other than making the entire system scale, this probably isn't the best approach given the efficiency of the human brain. And so what I think is really interesting is the concept of neural link, but not in terms of controlling things with your brain, but augmenting knowledge and data, and with a velocity that maybe a computer can provide, interfaced with your own brain. I mean, and that's probably another domain of science and research that has a completely different vector associated with it and roadmap. But I think you're spot on about this probably not being the optimal path. But there's
it may be the optimal path for profit. Okay.
Well,
but if the goal is artificial general intelligence, I kind of agree with Gary Marcus, who thinks this is not the right way at all.
Yeah.
And there's many other scientists and researchers who also believe this is not. But doesn't mean that large language models is bad.
Oh
like I said, it's probably the fastest path to profit. So that's great. Go down that path.
Yeah.
But, artificial general intelligence it probably takes a different hardware approach. Everything I've read said things like neurosymbolic computing does not run well on a GPU.
Yeah.
It's more suited to a CPU, in which case we're probably going to be compute bound once we get the algorithms to the level where we need them. But also, there's a lot of sensor work that has to be done. Artificial general intelligence means you're going to have sensors. Think of robotics.
Yeah.
Mm-hmm. Okay, think of all the robots on stage behind Jensen at GTC.
Yeah.
The magic there was mechanical engineering, so these guys don't fall down.
Right.
But also a lot of sensor engineering. So they are taking things from a world around them and trying to learn from them. And that's going to be key. Artificial general intelligence requires that the intelligence continue to learn. So it's a continuously learning platform.
Yeah.
Unlike large language models, which have to be retrained. And yes, you can augment them with RAG and you can make them smaller with LoRa and so forth. But they're not constantly learning.
Yeah,
that's going to be absolutely essential for artificial general intelligence. So one of the key milestones, I believe.
And yes, that is probably one of the big misconceptions about large language models currently is that they are learning. They can learn if you retrain them, but then the cycle, they can be architected in a way and operated in a way where they learn, but they learn very slowly versus the flow of reality and current context, current situations, right?
Mm-hmm.
And that's an important point. And then when you start to bring these models down to a device level, right? So the on-device that Qualcomm and Apple and others are doing, the notion that these things are learning is probably not accurate, right? Mm-hmm. Unless they can tell you what that mechanism is, and even if they were able to articulate what that mechanism is, it's probably not going to be real time, right? It's not going to provide you with immediate adaptability that humans are able to, in large part, be able to exhibit in terms of behavior, right? And actual learning. So that's an interesting point that you're making. A good one.
It also, this whole thing of, can I get there through scale, or do I need a different approach?
Yeah,
that is huge, because if you can get there through scale, if all you need is more, then NVIDIA probably continues to win. Because that'll be developed on NVIDIA, and NVIDIA will develop the GPUs to accelerate those algorithms, and they'll continue to win. On the other hand, if you cannot get there through scaling, if you really need a different approach, like neural symbolic, or spiking neural networks or quantum, NVIDIA is going to have to reinvent itself. That's big when you're talking about a multi-trillion-dollar company reinventing itself. If anybody can, it's probably Jensen. But we'll see. I mean, I do think that large language models will get us close enough to artificial general intelligence that it will fool a lot of people. And as long as it provides real business value or scientific value,
Yeah.
creative value,
Yeah.
that's wonderful. That's
Yeah.
great.
Yeah.
But if it does reach a point where somebody like IGO is AIGO,
Huh?
a little company that's building neural symbolic software, if they can figure out how to accelerate that stuff
Yeah.
so that it can run faster, so they team up with a hardware group to provide some parallelization to speed up the math behind it.
Yeah.
That could be really big.
Yeah. One of the things that I saw at Semicon West that was interesting was this presentation by IBM, and I forgot the name of the gentleman. Sorry. I mean, this is just off the top of my head. So, and as you know, you and I, we go to a lot of conferences and see a lot of things during the course of a year, so we remember everything. But what I do remember is on the slide, what comes after the GPU is analog, right? These analog accelerators, and I think that's one of those domains that IBM is looking at. And it's interesting how progressive IBM is. When we talk about AI, oddly, even though they have Watson, they have Project Debater, and all these great demonstrations of how they laid the foundation, or at least were pioneering a lot of things that we're wowed by today. They're not necessarily looked upon these days as a AI leader, right? Mm-hmm. But when you look at what their R&D group is doing, IBM Research has been doing for years. It's pretty amazing. But it's interesting that you're bringing a lot of this up, because it does suggest that the current AI compute technology may not be attuned to taking even the LLM to the next level. And speaking of scale, one of the big challenges I think that the current model is going to suffer is the challenges of continuing to scale the power. It's not scaling as quickly as the compute, right? The curve, or Huang's curve, as NVIDIA calls it. I don't know. Have you ever heard of Huang's curve?
I haven't. No. I mean, I'm sure
You of all people, I thought
I haven't heard Jensen speak of Huang's curve. He's not a very egotistical man, so I doubt he would call it Huang's curve.
I know. Yeah, I've heard it called other things, but it's a similar type of curve that shows sort of this exponential, increase or improvement in AI.
I've improved performance by 1,000-fold, so maybe that's
or whatever. Yeah, and apparently they call it Huang's curve, and I don't know when that was actually coined, but I saw it at Semicon West this last week. Oh my gosh, it was last week, and it was presented by someone from NVIDIA in one of their technical talks, and I was like, "Whoa, you got to be kidding me!" Huang's law, and so I think they're going to hit a wall, right, in terms of power. Because they've thrown almost everything you can imagine at the problem, from liquid cooling, which has limitations. It's pretty much a one and done, because that technology has been in play for a long time, and its ability to impact the energy efficiency overall for these liquid cooled AI computing deployments is going to be limited, right? It's like, okay, you've made that very expensive transition, and there's that new baseline, but what's going to continue to drive that benefit curve, and I think it's very limited. You have the precision, data type precision, which is going to hit a wall as well. I mean, if he's already at like int4, where else are you going to go? You're going to go to 2, and then what are you using this stuff for, right? Because the application of int4 is pretty limited based on what I've heard from a lot of researchers, unless you're trying to get on device like Apple, where I think Apple, with Apple Intelligence, when they deploy Apple Intelligence locally on an iPhone, it can go down to int4, I suppose. But, that's one of the things that they cite in their technical papers. But that's going to be the big challenge. And I think at some point, maybe once that LLM illusion is not good enough, and the power challenge is going to and maybe the sustainability concerns are going to drive everyone to look for something better. And I guess we'll see, right?
Yeah, I think I saw research yesterday that said that they said by the end of the decade, AI alone will consume about 1.5% of all the power in the world. And my first reaction was 1.5%. That's not that much.
Yeah.
But when you think about all the power in the world, you're multiplying 1.5% times a very large number.
Yeah.
And so it is. You also end up with power density problems where any urban area will not be able to provide the kind of power needed for, let's say, Elon Musk's new supercomputer. Can't remember what he called it, but it's basically the ultra supercomputer or something. He says it'll be the biggest supercomputer in the world. A lot of people are saying, actually, no, we have supercomputers that large already, Elon. Sorry, you didn't know. But yeah, power density and delivery systems are going to become a real issue because while many of us are excited about artificial general intelligence, as I said earlier, all the money right now is going to be made in large language models.
Yeah.
Or some derivative of large language models. It provides so much value. That's driving a lot of demand. And that's what's driving NVIDIA's sales of H100s and H200s now, and next year or later this year, the B200 and so forth.
Yeah.
So.
Right. Yeah, so I think I still think the jury is out on that. I know you and I differ on our opinions there, and we still have yet to see anyone actually profit from this stuff. I know that they're baking.
So that's interesting. I don't know if you saw this, but there's a lot of talk that Jensen will speak at this next earning conference about his experience and his customers' experience in generating profit. In his last earnings statement, he said that for every dollar you invest in an H100 over 4 years, you'll get $7 return on investment.
Yeah, I don't know. I really don't know what that.
He's gonna add substance to that. He's gonna have customers, I think, join him, or stories of customers at his next earnings call that will put the meat on those bones.
Okay, that'll be interesting,
and hopefully help convince Leonard Lee that you can make a lot of money on this stuff.
Well, I mean, I probably ask a much broader audience than he does about this stuff at a much more tactical, practical level, and I don't see too many cases that justify the amount of infrastructure that's being built out, and so I think. Even amongst some of the bigger players, I'm not going to name names, but some of the bigger players who are his customers, I think they're still early in the sales cycle, prospect cycle, and there's still a lot of challenges getting, especially on the enterprise side, these solutions out at scale within the organizations. And so I guess we'll see, but it's also it'll be interesting. Hey, I don't I don't mind hearing what he has to say and what he's experiencing. If there's real, case studies where there is a trend toward profitable businesses being built upon this technology, then yeah, let's see it. Again, profitable revenue, generating revenue is one thing. But we all know that this form of computing that supports generative AI, the current generations of generative AI, is very expensive, right?
Very expensive.
These curves are hypothetical. If you drill into the details, they're not all that they're cracked up to be, including Huang's law, this curve. And then there's a lot of other countervailing trends that could, take the air out of the AI supercomputing balloon, right?
Well, everybody's expecting the Gartner hype cycle to kick in, right?
Yeah.
So if you're familiar with that curve, are we at peak expectation, unrealistic expectations for generative AI? I think we're kind of there, which means the next step is down. It's the trough of disillusionment.
Yeah.
And I think we probably are headed towards a trough of disillusionment. Meanwhile, everyone's going to continue to try to get us to a sustainable, profitable level, which will require a lot more GPUs. And so a trough of disillusionment does not mean a trough of revenue for NVIDIA. I think that's the dichotomy that a lot of investors are struggling with right now, because they know we're going to get disillusioned. The question then is, well, does that mean you buy fewer GPUs? Intuitively, the answer is yes. I suspect the promise of greater riches down the road will lead people to continue to invest.
Well, here's the other dichotomy. The weird thing that everyone has to reconcile. You mentioned AMD, so let's talk about Computex really quick.
Yeah, sure.
It was there, right? And Lisa Su did get up on stage and say, hey, we're going to go on a 1-year cadence like NVIDIA. You mentioned that earlier, right? And then, of course, they unveiled the MI 325. And, of course, they're looking at continuing to, chip away at NVIDIA.
They're going to try to close the gap. They're going to try to close the gap. And I may have mentioned this on a previous call. Maybe it was a different media platform, but NVIDIA's version of yearly cadence and AMD's version of yearly cadence are very different. NVIDIA's yearly cadence is really a 2-year cadence with a memory bump in between. Okay, with higher capacity, high bandwidth memory. Probably have to turn the silicon just to get enough bandwidth. But it's not an architectural change. AMD's is an architectural change. They're going to have a new architecture next year. And meanwhile, they're going to do another GPU this year on the existing architecture. So that is what it takes to close the gap, is the pace that AMD is on. The question I have is that pace realistic? Is it sustainable? AMD, Mark Papermaster, they have done a fantastic job of not missing any development schedules. Well, now they're going to an annual cadence with a new GPU architecture every year, or maybe new architecture every other year, but a new GPU chip. It's more than just high bandwidth memory yearly. That's going to put tremendous stress on the resources at AMD. If they're going to catch up, that's what they need to do. I agree. Good job, Lisa. But it becomes an execution risk that they haven't really had in a lot of years at AMD.
Yeah, but one of the things that I'm becoming more impressed upon, and we touched on this on our GTC chat, is the importance of interconnect, even more than CUDA. The software, I don't think is as and this might be a heretical statement, is as differentiating for NVIDIA as people might think. I think what really makes NVIDIA stand above the rest is all the interconnect, NVLink, InfiniBand, and then this holistic architecture that they put together, right? And that's, I think that forces a transcending of the conversation beyond just the chip, right? And it's definitely becoming more about the system. And so the big question for Lisa and everyone else, including Intel, is how are you going to scale this stuff? Because when it comes to large language models and beyond, it's like what you're saying, it's all about scale. And UA Link, which AMD made a big deal about, Intel made a big deal about, in terms of standard, doesn't look like it's going to gel or deliver anything, substantial from a commercial standpoint for another 2 years, 2 to 3 years.
Mm-hmm.
And so what's going to bridge and provide acceleration in between, and how quickly can AMD get Infinity Fabric up to competitive par, right? I mean, I think those are, like, for me, more of the important things for the competitors at the moment, because everyone is, despite what what NVIDIA says, is bound by Moore's law, right? Whatever that means. But if it's slowing, everyone has to deal with that as well. If it's getting more expensive to go to the next node, everyone's bound by that, including NVIDIA. NVIDIA, with all their machinations, can't get beyond that constraint because, there's
A lot of the constraint you're referencing, I totally agree with you. A lot of the constraint that they're all suffering under right now is everybody using PCIe 5, right? The physical, the part of the chip that turns digital into analog signals over a wire, right?
So they're using copper.
They're all using PCIe. And so they're going to be limited by PCIe until they come up with a new PHY. I don't know what UA Link's going to do about that. If it runs over PCIe Gen 5 or Gen 6, they're still going to be at least an order of magnitude slower than NVLink, which is not using PCIe PHYs, uses an NVLink PHY invented by NVIDIA Research. So there's a fundamental issue there that Intel and AMD and everybody else are going to have to get past. And it's interesting that is actually the reason why, if I can overstate it just by a little bit, the reason why Cerebras is so much better than a GPU. They're not going out through a PCIe PHY. They're going from chip to chiplet. The dies on a wafer, and they're using direct connectivity between those chiplets across that wafer. And that's what makes them so fast. And so as long as I don't know what the plans are, I've not been briefed on what the plans are to get past that problem. I mean, it's a nice problem to have, because if you're just running it on PCIe, you can just run it over Ethernet, and everything's really, really easy to implement. Like IBM, you mentioned IBM, they built their supercomputer, which is all based on A100s, not even H100s, but they interconnect them all through Ethernet, because that allows them to have basic containerization of the AI workloads across the fabric. That's really nice. That's really easy to implement, but it's slow compared to what you can do with NVLink.
And I think one of the things that I've been telling a lot of the folks that I advise and chat with, it's we have to recognize a lot of what's happening here on the compute side of things, even more than, let's say, the AI PC, is some really interesting and potentially it is a bit disruptive stuff happening in supercomputing, right? And so when we look at the kind of workloads that are being put onto these NVIDIA, systems, I mean, there's supercomputing workloads. And when you go and you listen to the presentation, a lot of the stuff, actually, we've seen these things for years, right? From NVIDIA, because they've been used in, a smaller scale, quote unquote, supercomputing and modeling. But now they're in a way democratizing supercomputing and making it like what we mentioned before in our our GTC discussion, more general purpose, right, and more accessible. And I think that's the interesting thing that NVIDIA has done, and the role that the software plays, I think, in enabling this extensibility of their quote unquote platform, supercomputing platform. And it's I thought you would eventually mention Cerebras, and I think they're interesting because they introduce a different way of thinking about the supercomputing architecture, right? And then an entirely different approach to actually designing and making your accelerator. And they also have innovative software, right? Because obviously you can't get 100% yield. They have over 900,000 they have over 900,000 cores on that thing, almost a million, right? And then there's software just basically ignores all the defective cores, and you get whatever the 90% or the 80% of good cores that are exposed then through the software. And so the developer doesn't even know, right? And it's just a really, really clever,
very clever,
I think.
Yep. And they can. It's interesting. The code required to build a large training platform on Cerebras is the same if you're going to use it on one box or 1,000 boxes. The only thing that changes is the variable on one line of code that says basically n equals 1 or n equals 1,000. The rest of the software stack doesn't change at all.
Yeah,
that's pretty remarkable. And I would also point out, while GraphCore, my dear friends in the UK, they've finished their acquisition with being acquired by SoftBank at pennies on the dollar. Andrew Feldman's probably going to go public later this year. All right. He hasn't confirmed that, but there's a lot of rumors in the industry that he's filing all the paperwork needed to go public later this year. So that's one level of success. Whereas everybody else, all the rest of startups are still operating on expensive venture capital. And do not have the kind of track record investors will need to see to be able to fund the business through a public offering.
Yeah, and maybe that's what it takes. Is a really, really big chip.
Takes a different approach.
Yeah.
Often said, congratulations, AMD, you've got a great chip there, but you're still trying to outdo NVIDIA at their own game.
Yeah,
and that's good. Maybe they can get 20% of the market that way, though. And there's probably 20% of the market that are adequately price sensitive instead of performance sensitive, and they're not running traditional HPC workloads, so they can just use the code, download it from Hugging Face.
Right.
That gets around the whole CUDA problem, to some extent. But what Lisa said, $4.5 billion, I think, is her current estimation of how many MI300s. I think they'll probably do 6 billion this year. I'm pretty bullish on what they're doing. That's still 5% of what NVIDIA is going to do. So
yeah. And then you know what? It's going to be interesting. I think the big question mark at the moment is Apple Intelligence. Part of that is a mysterious server, right?
I
Apple
know.
Silicon server. And you know what? I think this is probably like the most intriguing thing
They're
because,
not saying,
yeah, it's like, okay, what the hell are you guys
what
doing
the hell are you doing?
here? You know? But if you think about it, Apple has been on the leading edge of, chip design and packaging as well. People oftentimes don't associate Apple with this. I mean, if some of the most advanced packaging is on your Apple Watch, right? With the
Mhm.
S1, where they used system and package to in that chip design, right? And so yeah, I'm just really curious how do you scale an M series chip? It's probably like a Ultra or a M3 or M4 ridiculous, you know? Probably like four of these things stitched together, like a four of M4 Max stitched together or something like that. Who knows? But
Probably.
how they would be able to scale this thing out in a way that is better than what you can get with NVIDIA systems, right?
Yeah.
Because you would argue
It's
that they have the most energy efficient, or per watt efficiency of you know, any provider out there, right? Any vendor out.
Qualcomm would disagree with that, I'm sure.
Yeah. Yeah, big time, big time. Well, who
Big
knows?
time.
They might have their own server stuff coming at some point as
Well,
well.
I think it's likely. When I was down in San Diego a couple of weeks ago,
Oh
while
yeah.
the official word is we're not saying anything about Cloud AI 200.
Uh,
No comment. But if you talk directly with the engineers, yeah, there's a Cloud AI 200 in the works. I don't know if they've caped out yet.
well,
I would imagine
yeah,
they're they've got bigger fish to fry with the AI PC,
yeah,
but and automotive, big focus
yeah. Big
on
automotive.
Qualcomm's
Yeah,
big focus on automotive.
yeah,
Where by my math, their automotive pipeline is more than twice that of NVIDIA, which really
yeah,
surprised me.
yeah.
Um, so, but at any rate,
Actually, it's
I
been
would
tracking that
expect
way.
to see another data center platform from Qualcomm next year.
Yeah, well, they're already doing that. They're already doing that thing with Cerebras, right? And they're going to be
Yeah,
using AI 100
using the A100 Ultra.
yeah,
Yeah. Hmm.
for inference.
Yep.
So, and I think Qualcomm, that's something that I don't think a lot of people know about Qualcomm, is that they are
Yeah.
in supercomputing.
Yeah.
They're an accelerator, but then even in the RAN, they have some of the best accelerators for the RAN. So yeah, in that regard, Qualcomm, yeah, definitely have a portfolio of technology and products that could position them pretty well for some accelerated computing especially across the quote unquote hybrid
Hmm.
cloud domain. And but yeah, with Apple Intelligence, it's they're definitely going to have a large scale need, right? Whether it's revamping Siri, or supporting a lot of these new Apple Intelligence services, which I think they're going to try to minimize. They're going to be trying to push as much on device as possible, right? But still, it begs the question. Oh, well, what kind of game do you have going on here on the server side with your own Apple Silicon, right?
Right. Yeah.
Yeah, and then I think some
The-
of the TSMC numbers are. I know you didn't want to talk about them, but I think some of the TSMC results this quarter give you a little bit of a hint. So
they definitely they said that it's all driven by AI. And that's basically two companies driving that volume.
yeah,
Three, Qualcomm and NVIDIA and AMD.
yeah, yeah, yeah. So yeah, and oh. One last thing. I just wanted to see if you had any thoughts about Rubin. We didn't get to chat after Computex, at least didn't get to chat much, but what did you think about that announcement coming out of?
It's,
Yeah.
it's kind of content free. It didn't say a lot about Rubin, and nor do they need to say a lot about Rubin.
Yeah.
People are still trying to comprehend the impact of Blackwell. So, you know,
Yeah.
suffice it to say, there's another one coming in 26.
Yeah.
So, okay.
Do you think, yeah, do you,
Pretty amazing.
okay, so going back to this whole 1 year cadence thing, do you think that that, that, NVIDIA's customers can digest this stuff this quick?
Oh yeah, because they're not going to retire what they've already acquired, right? They're not going to decommission the A100s for a while. They'll continue to use those even as they buy Blackwell. So that's two generations.
Yeah.
So I think you can easily see them. Their customers can stomach maybe three generations at a time. So now that would be A100, H100, and B100. The economics don't justify ripping out the old A100s yet, but sometime next year you'll start to see those being taken out. I don't think their customers, their large data center customers, will struggle to justify multiple generations live in the data center. That if that was the case, we'd already see H100 start to fade, and it's not. I mean, everything I'm reading right now says H100s. They're sold out probably through. We've been all saying since till early 25. What I'm hearing now is H100s and B100s are all pretty much sold out through 25 and 26.
Really? Wow.
Yeah. Some recent stuff just came out yesterday, I think, where people doing channel checks are finding there's no slowdown. People that think there's a slowdown are self-serving short sellers, I think.
I was going to say something clever. And
that would be nice. Let's do it.
Yeah, no. No. So anyway, well, I guess we'll leave it at that.
You get the final. That's clever. Come on, Leonard. Don't let me down.
No, I totally forgot what I was going to say. I'm sorry. I was just just completely steeped in your comment. So, you have to forgive me. This is going on an hour. So
yeah, it's a long chat.
Quite a catch up. So this is awesome.
Yeah.
But hey, Karl, thanks for joining me. It's always great having a discussion.
Always fun talking with you.
A lot of great insights. I think it's going to be a really interesting time over the next 6 months as we see all this stuff play out. I mean, there's a lot of volatility that we can look forward to, right?
That's for sure.
Yeah, and I think it's fun. This is just really fun for me, and I know that it's fun for you. And why don't you take an opportunity to share with our audience how they can get in touch with you and tap into your research?
Just Karl with a K, KARL.FREUND at Cambrian-AI.com, Cambrian-AI.com.
There you go.
Reach me that way, and or follow me on Twitter and LinkedIn and Forbes, where most of my articles show up. It's on Forbes. And of course, Cambrian-AI.com. If you want to go back and see anything from the last 5 years of AI, just go to Cambrian-AI.com.
Absolutely. Awesome. So everyone, thanks for tuning in. Remember, please subscribe to the Next Curve YouTube channel. The easiest thing to do is to subscribe to the Next Curve Research Portal and Media Center at www.next-curve.com for a constant diet of the tech and industry insights that matter. And with Karl Freund on our program here, and our joint collaboration, all the AI computing, supercomputing stuff that matters. So we hope you join us next time. Take care.
Take care. Bye-bye.